After assigning the support to the frame structure, now we will define and apply load on it. So go to load and definition. After that, click on load case details over here. So we have to define the loads that we want to apply on this frame. So left click, and after that click on add. Here also we will add two kinds of load, that is the dead load and the live load. So number one load is dead, load type is dead, click on add. So second load is live load, so live load, and the load is live, click on add, click on close after that. Okay, so we have defined two loads, but we haven't yet applied the load on our structure. Let us define the loads within the dead loads. Left click on the dead. So here we got different kinds of load. Okay, this load over here will apply as the dead, this load also will apply as the dead, and this load will apply as the live, and this load also will apply as the live. So as I have already told you, as this is just an example of a frame, you have liberty to choose between the dead and the live load. But when you are doing a building, so certain loads are applied as the dead and certain loads are applied as the live load. You don't have any option over there. Okay, now let us define the dead load. Apart from these two loads, we got the self weight of the structure as well. First we will define the self weight. So left click on the dead, and after that click on add, and here check the self weight load option. So the factor should be -1, so we know why it is, and after that click on add. Alright, so the next we do is the member load, and the member load we got concentrated force. The unit value of the force is -10 kilonewton, and it is applied in the GY direction, and minus means the downward direction. If you see this, if we take this beam over here as an example, so if we apply on this beam, in that case the D1 distance here is 3 meters, and if we take this beam here, in that case the D1 distance is 0. So we will take this beam here as a reference and put the D1 value as 3 meters. Okay, so D1 is 3 meters, and we click on add. The next load that we are applying is the uniformly varying load of the dead nature. So this is the dead load of intensity 2 kilonewton per meter. So what are we going to do? We'll apply the linearly varying load. So we are applying this kind of load, okay, not this kind of load. This is W3. Check this option W3. The unit is, or the intensity is 2 kilonewton per meter. We are applying here. So this is positive X from left to right. We are applying from right to left, so it's negative -2 kilonewton per meter. So -2 kilonewton per meter, direction is X direction. So click on add. So next load that we apply is the live load. So we don't have any dead loads, so click on close. After that click on live option over here, live load, and click on add. So we got live load as 4 kilonewton per meter distributed load, 7 kilonewton per meter uniformly varying load. So let us apply this. It's a member load and it's a uniform force. So W1 is -4 kilonewton per meter, and D1, D2, D3 are 0 in this case because we are applying in the full span. So there is no D1 value and there is no D2 value, and as we are applying at the center of the beam, there is no D3 value as well. Okay, so save it. It's -4 and the direction is GY, that is the Y direction. So click on add. So next load that we are applying is the linearly varying load, and here W1 is 0. So in this case you can see that there is no load at this point, so W1 is 0 and W2 is 7 kilonewton per meter. So W1 or the load intensity at this point is 0 and load intensity at this point is 7 kilonewton per meter, and the direction is y, so it's -7. And click on add. After that, click on close.